Welcome to Scale Up University. Welcome to the course on building applications with AI agents. So this is the lecture number 11 of module 1. And in this lecture, we will discuss modularity in agent design. So if we look at the lecture overview, like what we will be discussing in this lecture, like what this lecture is about. So see, most early AI systems, they failed not because they lack intelligence, but because they are monolithic in nature. So most early AI systems, they fail not because they lack intelligence. Despite them being intelligent, they still fail because they are monolithic. So monolithic agents. Now monolithic means these monolithic agents, they couple reasoning tight to tools. So if there is a tight coupling is there, then it is like monolithic. In monolithic, the coupling is like tight, coupling between the reasoning and the tools. Monolithic agents, they embed assumptions everywhere. They breaks when one part changes, and it is very difficult to upgrade monolithic agents. So the idea is very clear. Like when you're trying to scale monolithic agents, it will start breaking. It is not at all scalable, and hence early AI systems, they fail because they are monolithic in nature. And that is what we will discuss in this nature. So in this lecture we will discuss that only, that whenever you are designing agents, you have to go for modularity. So you should design modular agents and not monolithic agents. So modular agents, if we talk about, a modular agent is not a single block, it is a system of interchangeable parts. And in this lecture, we will discuss in some good detail, like how to build modular agents, modularity in agent design. So that is the main crux of this lecture. So if we look at the topics that we will cover in this lecture, so we'll discuss what modularity means for agents, composable systems, component based agent design, separation of concerns, clear interfaces between components, plug and play skills, swappable models and tools, easier maintenance and upgrades, faster experimentation, modularity enables multi-agent systems, anti-patterns to avoid, and finally we will conclude this lecture by discussing the bigger philosophy. So all these topics we will cover in this lecture itself. So this is the module 1, Introduction to Agents, lecture 11, Modularity in Agent Design. And we are starting with the first topic of the lecture, that is what modularity means for agents. So in simple terms, modularity means dividing a system into independent components with well-defined responsibilities. So modularity means we divide a agent system into independent components with well-defined responsibilities. So for agent systems, modularity typically means separating perception, reasoning, planning, execution, memory, monitoring, and policy enforcement. So in agent system design, like we can separate the agent system into different modules, wherein every module is like an independent component with well-defined responsibilities. Like we can have perception module, which is responsible for receiving the input signals, that's a perception. Then we have reasoning module and planning module, which will basically build strategies to achieve the goal, because we already know that every agent is goal driven. It is working towards accomplishing a goal. So planning is like set of actions which needs to be taken, and reasoning will help in deciding, in decision making, like out of all the tools, which tool should we use to solve a particular problem. Reasoning will also play a role in reflecting, like assessing the outcomes and adapting, revising and refining the strategy. So we can have a perception module, a separate reasoning module, a planning module, a separate execution module. Execution module will be responsible for executing the set of tasks. We can also have a memory module which will store the context. We can have a monitoring module which will monitor the actions, the outcomes of it, and which will keep on monitoring whether the agent, it is going towards achieving the goal. Monitoring ensures that agent is not drifting away from the goal. Monitoring also ensures guardrails and all that, and policy enforcement. So in agent system design, we can have these all modules, wherein each module here has a clear goal, can be improved independently. This is very important. Every module which we have discussed here, it has a specific clear goal. Each module can be improved independently, and each module can be replaced without rewriting the entire system. And this is what makes agent systems, like the modular design, modularity in agent design, very powerful. Like we can plug and play, we can replace modules without rewriting the entire system. We can improve modules independently. So now you got a basic understanding like what modularity means for agents. Composable systems. So a composable system allows new components to be added easily. Like with composable system, as the name suggests, composable system, we can add new components very easily. We can rearrange existing components. So existing components can be rearranged. And a composable system allows capabilities to be combined dynamically. In agent design, composability means combining different skills, orchestrating different tools, layering reasoning modules, and supporting multi-agent coordination. So composable systems, it's very clear that composable system means the system is composable, new components can be added, existing components can be rearranged, and capabilities can be combined dynamically. So in agent design, composability means we can combine different skills, wherein we can design agents which can retrieve information from the web, which can do the sentiment analysis, or n number of functionalities which can convert a text into PDF. So we can combine different skills in a composable systems, in a composable system which is like a agent system. In agent design, composability means orchestrating different tools, layering reasoning modules, and supporting multi-agent coordination. So in agent design, instead of hard-coded pipelines, which we have been doing in machine learning and deep learning. So in traditional machine learning and deep learning, we had a hard-coded pipeline wherein we used to get the input to the data, we used to pre-process it, we used to do feature engineering, then train the model, then evaluate the model, then test the model, and then analyze the results. It is like a hard coded pipeline. But in agent design, we build configurable, reconfigurable architectures. So here the pipeline is not hard coded, rather it is configurable and also reconfigurable architectures. So the idea is that the agent system, if we talk about, it is modular in nature. So now I hope you got a very good understanding about composable systems. So modularity in agent design means we will be building composable systems, composable agentic AI systems, component based agent design. So modularity in agent design means component based agent design. So see, a mature agent architecture might include input interface module, wherein the input interface module, it will handle user interaction. It is responsible for validating the input and which normalizes the request. A mature agent architecture will also include planning module, or before that, like we can discuss the reasoning module. So reasoning module, so we know that every agent is working towards accomplishing a goal. So reasoning module, it makes use of the foundation model, like the LLM, large language model, to interpret the goals and generate plans, and also to decide when there are several options are available. Reasoning module will also help in deciding what decisions to take. Then we have planning module. Planning module is all about decomposing the task into subtasks, ordering actions, and tracking the progress. We have, like, a mature agent architecture involves execution module, which is responsible for calling tools, executing API requests, and handling responses. A mature agent architecture also includes memory module. So this memory module is responsible for storing context, maintaining history, and supporting retrieval. A mature agent architecture, it also includes monitoring module, which basically logs actions, tracks performance, and detects anomalies. A mature agent architecture also includes policy and guardrail module, which is responsible for enforcing constraints, validating outputs, and managing compliances. So component means module. So component based agent design, like we already saw in previous slides also, like we will be breaking the agent system into components, the modules, wherein we will be having input interface module, which will be handling user interaction, validating input, normalizing request. We will be having reasoning module, which will make use of foundation models, which will interpret goals, generate plans, and help in decision making. We will be having planning module, which will decompose the task, order actions, track progress. We will be having execution module, which will be responsible for calling the tools, executing API requests, handling responses. We will be having memory module, which will be responsible for storing the context, maintaining history, supporting retrieval. We will also be having monitoring module, which will be logging the actions, tracking performance, detecting anomalies. And we will be having policy and guardrail modules, which will enforce us constraints, validates outputs, and manages compliances. So each module can evolve independently, and we can replace the modules, and each module can evolve independently. So that is the modularity in agent design, like the component based agent design. Separation of concerns. So separation of concerns means each component should focus on one responsibility only. So separation of concerns means, see, we already saw the modularity in agent design, wherein agent system we are breaking into different modules, and we can also call it different components. Now, each component should focus on one responsibility only, and that is the meaning of separation of concerns. Now, for example, if we are talking about reasoning module, now this reasoning module should not have to deal with database storage, because the goal, the responsibility of reasoning module should be interpreting the goal and helping in decision making. Similarly, if I talk about execution module should not get involved in deciding goals. Rather, execution module should be responsible for executing the set of tasks and subtasks which we got in the planning phase, which the planning module designed, the set of tasks. So execution module should just execute that. Similarly, if I talk about memory module, it should not be concerned about enforcing policies. Rather, it should be responsible for storing the context and retrieving information. So this is the separation of concerns. And separation of concern is very important. So why this matters, why separation of concerns matter is, so it's very clear to us that separation of concerns, it reduces complexity, because every component, every module is focused on one responsibility only. So it reduces the complexity, it simplifies debugging. So let us suppose there is some issue with the goal. Like let us suppose the agent decided a wrong goal. Then we know that the problem is with the reasoning module. So we can just localize our focus. We can just focus on reasoning module, and the debugging will become easy. Rather than debugging the entire agentic system, we will be just have to focus on reasoning module of the agentic AI system. So it simplifies debugging. It enables independent scaling. Now we can scale modules independently, and it improves reliability, because under stress, let us suppose in uncertain situations also, system will be able to handle failures gracefully, because now with separation of concerns, the agentic AI system, it becomes fault tolerant, because for every module, for every component, we can like have a different fault tolerant policy or a mechanism. For reasoning module, the fault tolerance will be different as compared to execution module, and overall we can make a reliable system. So we can improve the reliability of agentic AI systems. When responsibilities blur, like when multiple modules are involved in doing the same things, systems become fragile and unpredictable, and that is what we don't want. So now separation of concern is very clear to us, wherein each component is focused on one responsibility only. Clear interfaces between components. So modularity only works if components communicate clearly. Modularity only works if components communicate clearly. And hence, clear interfaces between components is very important, because we already saw that in agentic system, we are breaking it into different modules, wherein, or we can call it like components also, and wherein every component is responsible in accomplishing one goal, and components, they function independently, but there is a need for the interaction between the components. So modularity only works if components can communicate clearly, and that is what clear interfaces between components means. So if I talk about clear interfaces, so clear interfaces define inputs, outputs, expected formats, and error handling behavior. So the idea is that whenever we are designing the component or a module, what inputs it can take, that should be very clear. So we should define, okay, this is the component we are designing, what inputs it can take, what outputs it can generate, what is the expected format for input and output, and error handling behavior. This is very important. So whenever we are designing a module or a component, error handling behavior plays a very important role. So let us look at one example. Like we have planning module. Now the output of planning module is structured action steps, because planning means action plan to achieve the goal. Now the output of the planning module will be the input of the execution module. So execution module will be provided the structured action steps which needs to be taken. Now execution module, what they will do, they will execute. So monitoring module, now what it will do is that, so the output of execution module will be the outcomes of those action steps, and monitor, that will be the input of the monitoring module. So monitoring module will get to know about the outcomes of each action step, because execution module will be executing those actions. So the outcome of every action will be given to the monitoring module, and monitoring module, what it will do, it will prepare a structured, it records structured logs. So here we saw that components, they interact with each other, and clear interfaces is very important, wherein there is a need that whenever you are designing a component in agent system, you have to define the inputs, outputs, expected formats, and error handling behavior, because without clear interfaces, modules become tightly coupled again. So that's where clear interfaces plays a very important role in agent system design. Plug and play skills. Now, like one of the most powerful aspect of modular agents is the concept of skills. Now, what are skills? First, let us understand that. So a skill may be a web search tool, a document analyzer, database query function, summarization capability, payment processing tool. So a skill may be any of these or many more. So a skill is like a capability. So when you are designing a agent system, you can plug and play skills. You can add whatever skills you want. For example, let us suppose here I have a modular agent core, that is the reasoning. So let us suppose this is the reasoning module. Now I can very easily plug and play different skills. I can plug web search tool. Now with web search tool, our agent system, now it acquired a new skill wherein it can crawl the web and retrieve web pages for us. We can also integrate document analyzer tool. With this, we added a new skill, a new capability to our agent system or a agentic AI application, wherein now it can analyze the documents. We can have database query function. So with this capability in place, our agentic AI application, it can interact with the database, it can query the database. Summarization capability. With this tool in place, our agentic AI application, it can summarize the text. And with payment processing tool in place, our agentic AI application, it can process the payment on its own. Now the good thing is that based on the scenario, our agentic AI application can decide what skill to choose. Like the reasoning module can help in deciding which tool to use to accomplish a particular goal or to solve a problem. So dynamically, the tool can be chosen by the reasoning module of the agentic AI system. So in a modular design, now see, this is a modular design. Why it's a modular design? Because every tool is acting like a component, a independent component with a specific functionality. So all these tools are independent components and we are just plugging it in our agentic AI application. So the idea is that skills can be added or removed easily. Like we can plug and unplug. The reasoning system can dynamically choose which skill to use. This is very important. The reasoning system of the agentic AI application, it can dynamically decide which tool to use based on the requirement. And one more very interesting thing, we can very easily add new capabilities. We can integrate new capabilities without rewriting core agent. So that is something very interesting. Like core agent, we don't have to touch it at all. We can very easily plug and play the tools which we want. So this makes modularity in agent design very powerful, because with modularity in agent design, we can have something called as plug and play skills, wherein very easily we can integrate new capabilities without rewriting the core agent. And this enables continuous capability expansion, the growth, swapping models and tools. So see, the idea is that if I talk about foundation models, like the large language models, they evolve rapidly. So if your agent is tightly coupled, if your agent is tightly coupled to one specific model or to one specific API or to one specific vendor, then it's a risk. It's a risk of vendor lock-in, like you are depending on a particular vendor. It's a risk of obsolescence. It's a risk of limited optimization. So the idea is very clear. Since agent system, they are modular, like if I talk about modularity in agent design, it also means swappable models and tools, wherein our agent system, our agentic AI application should not be tightly coupled to any particular model, any particular API, or any particular vendor. Rather, it should also be plug and play. So the model should also be plug and play, API should also be plug and play, and vendors should also be plug and play. And we can achieve that with modular systems, with modular design. So with modular systems, so modularity in agent design, it allows switching from one LLM to another. This is very powerful. So our agentic AI application, if it is modular in nature, very easily it can switch from one LLM to another. It can make use of different models for different tasks. It can route simple tasks to smaller models, and we can upgrade models without system redesign. So this is very powerful, the plug and play capabilities, wherein without altering the system at all, very easily we can plug new models. We can remove outdated models. So that is the swapping models and tools. So swappability ensures future proofing. Swappability ensures future proofing, easier maintenance and upgrades. So see, when systems are modular in nature, bugs are isolated, because see, we have different models, different modules or different components, each with specific responsibility. With the nature of the bug, we can very easily, we can like identify the origin, like where the bug is, what is the source of the bug. Like if the bug has to do something with the execution, we know that we have to debug the execution component or the execution module. If the bug is in the planning phase, we know that we have to debug the planning module. So with modular designs, when the systems are modular, bugs are isolated, improvements are localized, testing becomes easier, and upgrades are less risky. Upgrades are less risky. Let us look at one example. Let us suppose we saw that tool execution failed. Then we know that since tool execution failed, the problem is there with the execution module. So we will update the execution module and not the reasoning module. So the we were able to localize or isolate the bug. And with this, what benefit we will get is this reduces the downtime, the deployment risk, and the technical depth. So this reduces the downtime. Why it reduces the downtime? Because once we were able to identify the source of bug, very easily we can debug. So the debugging will be very fast. So we will be able to reduce the downtime, and hence we will be able to reduce the deployment risk and also the technical depth. So ultimately, maintenance becomes manageable instead of overwhelming. So with modularity in agent design, we can achieve easier maintenance and upgrades, wherein maintenance becomes manageable instead of overwhelming. So we can very easily focus on modules, we can upgrade them independently, and we can very easily identify the source of bugs and debug the modules accordingly. Faster experimentation. So innovation thrives in modular systems. So basically the idea is that with modular agents, we can experiment with new planning strategies, because with modular agents we can experiment with new planning strategies. The meaning to say that we can just focus on the planning module and we can try to innovate it, we can experiment without affecting other parts of the system. That is a very powerful feature. So I can independently just focus on planning module and experiment with it, rather than without altering the other components of the system. I can swap prompts or policies. I can add new tools because of modularity. I can try alternative model configurations, and I can also perform A/B test reasoning pipelines. So modular agents, it enables innovation. Innovation thrives in modular agents, and now it's very clear to us how, because every module I can innovate it separately without affecting or without touching the other parts of the system. I can experiment with the modules. I can try out new strategies. And in this way, I can get best results out of my agent system. And we are able to achieve this because components are isolated. Since components or the modules are isolated, experimenting with a particular module, it will not destabilize the entire system. Very easily we can roll back the changes, because changes we will be doing in a particular module, and very easily we can roll back it, and the effects, the impact or the outcomes of the new updations, the new upgradations, that can be measured independently, because we know that we have a agentic AI system. Now we are adding new planning strategies, and we can very easily measure the performance. And if we feel like it's not good, rather the performance degraded, then we know we only made changes in the planning module, we can roll back. And if we feel like, oh, it it improved the performance of the agent system, then we can keep it. So the idea is that we can measure, we can assess the impact of the changes of the experimentation we did. So the idea is modularity accelerates iteration speed. Modularity accelerates iteration speed. Modularity enables multi-agent systems. So see, the idea is that modular design, it makes it possible to convert a module into an independent agent. So with modular design, we can convert a module into an independent agent. Modular design also makes it possible to assign roles across multiple agents. So we can assign different roles to different agents, like role A, role B, role C. Modular design makes it possible to coordinate through defined interfaces. So this we already saw. So the idea is very clear. Modularity in agent design is very powerful. Because of this, we can convert a module into an independent agent. We can assign roles across multiple agents, wherein one agent can play the role of a project manager. We can have an agent which can play the role of a graphic designer. We can have a agent which can play the role of a software engineer. So that is the thing. We can assign roles across multiple agents, and we can coordinate through defined interfaces. So without modular thinking, multi-agent design becomes chaotic. So if you want multi-agent design, multi-agent systems, modularity plays a very important role. So modularity enables multi-agent systems. Okay, anti-patterns to avoid. Okay, now we will look at some anti-patterns which we should avoid while considering modularity in agent design. So we should not do this. So we should not embed business logic directly inside prompts. So this is very important. Prompts should only contain the goal needs that we need to be accomplished and along with the context. Business logic we should not embed directly inside the prompts. It can be very messy. We should not hard code tool sequences. Rather, let the reasoning component of an agentic AI system decides the tool sequences, which tools needs to be called. We should not mix reasoning and execution tightly. We should keep reasoning and execution separately. Otherwise, it can be very confusing. We should not have any abstraction layers. No, so the idea is that we should have abstraction layers. No abstraction layer is anti-pattern because if see what is abstraction layer? Abstraction means hiding the complexity, because the end user should not be exposed or should not be told about how the system is working. So hiding the implementation or the internal complexity from the user is abstraction. So no abstraction layer is an anti-pattern. So in modular design, we have to make it abstract, wherein every module should not know how the other module is functioning. Rather, it should know that what input needs to be given and what output that module will get. So no abstraction layer is an anti-pattern. We should avoid it. Rather, we should have abstraction in picture, and we should not have vendor specific dependencies everywhere. That can be very dangerous. There should not be vendor specific dependencies everywhere. So the better approaches, the best practices that we should consider while considering modularity in agent design, we should define clear contracts like the stable interfaces, wherein every module should have a very clearly defined input, output, the formats, and error handling mechanism. We should separate reasoning from execution. It will enable modular flow. Abstract model calls. Model calls we should abstract means we call it agnostic design. So the idea is that how the model is performing, like model means foundation model, the LLM. Now, agentic AI application is not at all concerned that how the LLM is giving the response. It is only concerned about, okay, this is what I want and what I am getting. Agentic AI application is only concerned about that. How LLM is giving that response, LLM like agentic AI application is not at all interested in that. So when we are talking about modularity in agent design, we should abstract the model calls. We call it agnostic design. We should maintain tool registries which will enable dynamic discovery, because if tool registry is there, LLM is aware about the available tools and it can dynamically decide which tool to call, which tool to execute. So we call it dynamic discovery. Use configuration over hard coding. So this is very, very important. We should avoid hard coding. Rather, we should use configuration and let the large language model reason and decide what to do. So it will make your agentic AI system very flexible and adaptable. So that's the idea. Modularity in agent design. Now we will discuss the bigger philosophy. So it's like a conclusion we are discussing. So modularity is not just an engineering technique. Modularity is not just an engineering technique. Rather, it is a mindset. It reflects a mindset. And modularity means build systems that expect change. And that is what, see, any application you are building now, it will keep on evolving with time. And if your application is modular in nature, very easily it can adapt to the new user requirements, to the evolution. So with modularity in place, our agentic AI system will be very flexible and adaptable. We will be building agentic AI systems that expects change, because it's a reality that with time agents, they must evolve. Agents, they keep on evolving, they keep on scaling, expanding, integrate and adapt. So modularity makes evolution possible. Modularity makes evolution possible. So finally we concluded this lecture, we completed this lecture. So now I hope that you got a very good understanding, like what modularity means in agent design, why separation of concerns prevents brittleness, how plug and play skills enable growth, why swappable components future proof systems, and how modularity accelerates experimentation. So I hope you got a very good and a clear understanding of the concepts which we covered in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures and courses. Thanks for watching. Thanks for your time.